This video will cover the lesson solving quadratic equations by formula. So for this lesson, you need to have a handout, a highlighter, a pencil. So we're going to go over this a little quick because our final exam is approaching, right? We have finals next week. And so we don't have time to cover everything. I wish I could do more examples with you. Unfortunately, we cannot. So complex numbers. So all the quadratic equations that we've been solving up to this point have had two real solutions or two real roots, and in some cases we had something such a double root, right? The same root or solution repeat. But they were always two solutions. Now, if we look at the equation that we have listed here, let's go ahead and answer the questions for that one. So, can this equation be factored in order to find the solutions or roots? So let's go ahead and try to factor it. We will have x plus, and the factors of 2, with 2 being a prime number, are only 1 and 2. So for this one, we use those numbers, and then we check our work by multiplying the two quantities on the outside. So 2 times x is 2x, and then the 2 on the inside, 1 times x, that will be 1x. If we combine them, that will give us 3x, which is not the term that we needed here in the middle. So what we could say here is no, we cannot find the solutions by factoring. Now, can the solutions be found by graphing the function x squared plus x plus 2? So if you could please graph that on your calculator. So as you can see, if we graph it, you could see that behavior. So Marco, could you repeat what you said?
There isn't a solution because it doesn't cross the x-axis.
It doesn't have we cannot find the solutions graphically because it doesn't cross the x-axis. It does not have x-intercepts that are real numbers. I'm sorry, it does not have x-intercepts. So what that means is that the zeros or the solutions are imaginary. So it does have a solution, we just cannot find it graphically or numerically by looking at the table. So we will say no, and let's use the statement that Marco gave us. No, because it doesn't cross the x-axis. However, that equation still has two solutions, but those two solutions are actually imaginary. They involve imaginary numbers. And so before we start talking and using operations with imaginary numbers, let's go ahead and define two things. So we're going to define two units, and one of them will be I. And so I is the number that you could get, that you can square. So if we take I and square it, you could get an answer of -1, which is pretty weird, right? Because up to this date, we always have known that if you square a number, you will get positive, right? So this was just defined, so we're going to use it by definition. I know it might not make a lot of sense to you, but that is how we're going to use it. So I squared is -1. So what that means is that if we have I squared is equal to -1, and we decide to take the square root on both sides, then that will give us our second definition. So that means that I is equal to the square root of -1. And so we're going to be simplifying negative square roots because you already know if you enter something like the square root of -4 on your calculator, you're going to get an error message or maybe something that says no real results or no real solution. So what we're going to be doing to answer those type of questions is we're going to take that negative sign and factor it out with a -1, like what we have here. Now, after that, we know that the root of a product is the same as the product of two roots. And so if we look at what is the square root of -1, by definition, it is I. And so that's what we're going to use here. All right? So let's get started with the examples. No, it's okay. So let's highlight this. When you have a negative number under a radical, you can take the negative out as an I. That's what we're going to be doing. Now I'm going to do it step by step so that you get used to it. So the square root of -49, I know that I cannot do that on the calculator. However, I can factor out that negative by factoring out -1 times 49. And from here, I know that that is the same as the square root of -1 times the square root of 49. From here, I know that the square root of 49 is 7, and the square root of -1, by definition, is I. Now, to check our solution, we have 7i squared. But if you notice, we have everything inside parentheses, and then the square is outside. So that means that we're squaring the 7, and we're also squaring I. 7 squared is 49, and I squared, by definition, is what? -1, right? I squared is -1. So every time you see I squared, you're going to substitute it with a -1. Okay? That is very important that you remember. So right here, going back, I squared is equal to -1, and if we multiply 49 times -1, that's how we get -49. Okay, next problem, the square root of -121. So we're going to factor the square root of -1 times 121. Here we could break this down as the square root of -1 times the square root of 121. The square root of 121 is 11. Square root of -1 by definition is I. Now to check 11i squared, we have to square the 11. We also square the I. 11 squared is 121. I squared by definition is -1. And of course, if we multiply those two numbers, we get -121. Okay, the next operation, we have something inside the radical. We have two numbers being subtracted, right? So 17 minus 42 will be -25. Here we could do the same steps. Factor out that negative with a -1 times 25. Here we got the square root of -1 times the square root of 25, and so this will be 5i. Any questions so far on that? I know I'm going kind of fast, but I will upload the video and you could watch it again. Yes?
That one right there where it's the -1 and the -25 split, that's just that one just split.
This one is equivalent to this. Yes. Okay, next one we have -3 inside the radical, so -1 times 3. The square root of -1 times the square root of 3. The square root of 3, it does not have an exact solution, so we're going to leave it like that, square root of 3. And the square root of -1 from here, by definition, is I. And notice how I'm writing my I on the left side. And the reason I do that is because I don't want it to look like this. Like the I is inside the radical. Okay, so that's why we write it on the left side of the radical. All right, the next problem is what you're going to encounter when you're using quadratic formula and you have a quadratic function with imaginary solutions. So let's get used to those type of operations. So we have 12 plus, we're going to do inside the same thing, so -36 is factored as -1 times 36. Everything divided by 2. Then we have 12 plus, the square root of 36 is 6. The square root of -1 by definition is I. Everything divided by 2. So now I'm going to split the fraction. So 12 is divided by 2, and so is 6. So now to finish this problem,
Why is the I not next to the large 6 but on this side?
because in standard form, which is what we're going to do next, you want to write the coefficient separately from the I. But that 6 over 2 times I is equivalent to 6I over 2. Is the same thing. So 12 divided by 2 is 6, and then 6 divided by 2 is 3. So 6 plus 3I. Okay, any question? All right. Now, what I was saying about standard form, so that will look like this. A plus B, and then I would just simply be multiplying the imaginary coefficient. So a complex number is the sum of a real number and an imaginary number. And we write them in this form, and that is what we refer to as standard form. So any form, whether it is imaginary or real, could be written in standard form because they are all complex numbers. Remember, we said complex is the big set, real is a subset, and imaginary is also a subset. But the big thing is the complex numbers, the big set. So what we're going to do is write these numbers in standard form, A plus BI. We have to always write the real part first and then the imaginary. So in this case, it will be 25 is the real part, the imaginary is 0I. This one will be 0 for the real part and 25I for the imaginary. Here they want us to identify them, but I want to skip that part, okay? Here, this one is already in standard form, 3 minus 5I. I guess we could do this one. The real part is 3, in the imaginary is negative 5I. Right here, the real part is 0. The imaginary is 25I, positive. Right here, the real is 25, and the imaginary is 0I. Okay, now the next 3 require some type of work. So we need to simplify them. Right here, I will have 9 plus. I'm going to factor inside the square root of negative 144. I'm going to factor it using negative 1 times 144. Now, just like we did on the previous page, we could take the square root of 144, which is 12, and the square root of negative 1, by definition, is I. Everything is divided by 6. Now, if I split the fraction, I will have 9 divided by 6, and 12 divided by 6 times I. And I need to reduce the fractions, so 9 over 6, it can be reduced by dividing by 3, the top and bottom. 9 divided by 3 is 3. 6 divided by 3 is 2, so 3 halves. And here we could divide 12 divided by 6 is equal to 2. So final answer is 3 halves plus 2I. The real part being 3 halves, and the imaginary part being positive 2I. The next one, what we need to do here is combine the real part, so 3 minus 7. What is 3 minus 7? Negative 4. And then we combine the imaginary parts, 5I plus 8I. 5I plus 8I is positive 39. So in this case, the real part is negative 4. The imaginary part is 39. Now we could also multiply imaginary numbers, and so here I'm going to multiply 6 times this binomial, 6 minus 2i, and then I'm also going to take the positive 2i here and multiply it times the same binomial. So this will be 36 minus 12i plus 12i minus 4. When I get here, 2i times negative 2i, it will be minus 4i. What is I times I? You add the exponent, so it will be I squared. Just like multiplying, what is x times x? X squared. So I times I will be I squared. Then you guys notice what happens to the two terms in the middle, right? What happens to them? Cancel, they're opposites. So what did I tell you to do every time you see I squared? To substitute it with which number?
1.
Negative 1. So here we have 36 plus 4, which is 40. So now something interesting happened. We went from imaginary numbers to a result that is only real. And so that is actually very important. So the way you are going to achieve that is by multiplying numbers that happen to be complex conjugates. So complex conjugates, I hope you're highlighting where I'm highlighting, okay? Complex conjugates are imaginary numbers where they have the same real part, but they have opposite imaginary parts. Those are the conjugate of a complex number. So we have here an example, positive 2 plus 3i, and the conjugate is 2 minus 3i. So you only change the imaginary part to its opposite. If you notice, the two that I just multiplied were complex conjugates, right? Right here, 6 plus 2i, 6 minus 2i. And that is why I obtain a real result. If you add or when complex conjugates are added or multiplied, the result will have a 0i as the imaginary part. Okay, so we're going to write down the conjugates of all these numbers here. Before I do that, I would like to write them in standard form. So this is 25 plus 0i. The one here is actually 0 plus 25i. Okay, so Jasmine, what will be the conjugate of the first one? Letter L. So the real part should be the same, and the imaginary should be the opposite.
So it would be 25 minus 0i.
Yes, very good. Yes.
Why is the 20 with L? That the 0 is on the right volume and doesn't have to be on the left.
Because the standard form of a complex number is always going to be like that. The real part first, and then the imaginary. So that's why here for M, I'm writing the real part first, and then the imaginary. So in this case, we have the real, and then the imaginary. Okay? Yes?
Why don't we just put 25 instead of 25 minus 0?
Well, because we want to write them in standard form. But yes, what you said is true. For a number that is just real, the conjugate will be the number itself. All right, so for the next one, Javier, what will be the complex conjugate here for M?
25?
Yes, that's correct. So whenever you have a number that is only imaginary, let's say 25i, we call them pure imaginary. The conjugate will be the opposite of it. All right, now for letter N, Matthew,
-3 minus 6x.
very good. Luis, next one.
What?
Complex conjugate of this one. Oh,
-12 minus 5.
uh-uh.
No.
Plus.
Oh, no, yeah, plus, sorry. Plus 5i.
Okay. Next one, Andrew.
2/3 plus 1/5 of I.
1/5 of I. Okay, and last one, Lauren.
5 minus 5 square root.
I square root of 3. Very good. Okay, so now we're getting to the complex solving equations that will have solutions that will be imaginary. And so let's work with this one here. So some quadratics can be solved by isolating the variable. That means leaving the variable by itself, right? And so to do that, we might have to take the square root on both sides. So we have here 6x squared plus 96 is equal to 0. So my first step is to take care of this positive 96, move it across. The 96 is adding to the x, so once I move it, it will be subtracting, therefore is negative 96. From here, you see that 6 is multiplying to the x squared, so you need to divide by 6. So negative 96 divided by 6. And here what we will get is 16, negative 16 actually. If you divide negative 96 divided by 6, you will get negative 16. So now how do we undo a square? Square root. So now we have seen already that we will have no real solution, right? However, we could do the following. We could take the square root of -1 times 16. So in this case, we will have the square root of 16 is 4. The square root of -1 is I. However, here it's not only positive 4i, it's one more. And that will be negative 4i. So whenever you are dealing with an unknown quantity, such as x, we must consider both the positive square root and the negative square root. All right? So what are the solutions here? In this case, the solutions are 4i and negative 4i. Two solutions. Why are those two? Because, well, one of the reasons is that imaginary solutions always come in conjugate pairs. Another reason is because -16, or let's just talk about 16. 16 has two roots, -4 and +4. To prove it, you could show that 4 squared is 16, and -4 with a negative inside parentheses square is also +16. All right. Any other question from here? Okay, so moving on. We're going to complete this table. I'm going to go kind of fast. So simplified version of the square root of -121. If we factor that as the square root of -1 times 121, that will give us 11i. In this case, I'm only taking the positive square root of 121 because I don't have a variable. So I only take the principal square root, which is the positive. The real part is 0. The imaginary is positive 11i. I'm going to leave the conjugate column for you to work on at your house. In this case, we have -56. simplified is still negative 56. That means the real part is negative 56. The imaginary is 0. Next number, we're going to simplify a little bit. So this is 85 plus the square root of negative 1 times 169. And that is actually going to be the square root of 169 is 13, so 13i. That's the simplified version. The real part being 85, the imaginary being positive 13i. The next one, we have the square root of a fraction, which is the same as a fraction of 2 square roots. So we can keep the negative on the top, and the 49 will just be positive. So here we will have negative, and now the square root of negative 16, as we have seen before, will be 4i. The negative here is the negative that we had outside the radical from the beginning. Square root of 49 is 7. So what I could say here is that the real part is 0, and the imaginary part is negative 4/7 times I. Next one, 5 does not have an exact square root. So all I can do here is just get rid of the negative by taking the square root of I and then the square root of 5. The 5 will remain inside the radical. Still, the real part is 0. The imaginary part is positive I square root of 5. For number 6, the next problem, we're going to combine like terms. So 3 minus 9 is negative 6. 14i plus 5i is negative 9i. So the real part is negative 6, the imaginary is negative 9i. Now the last one, we're actually going to be multiplying 5 plus 2i times itself. And so when we do this, we will obtain 25 plus 10i plus 10i plus 4i squared. So this is 25 plus 20i, if we combine the two terms in the middle. And what did I tell you to do every time you encounter I squared? You substitute it with which number? Negative 1. So 25 plus 20i minus 4. Now we can combine the real parts, 25 and negative 4. And that will be 21. The imaginary is only 20i. So here the real part is 21, the imaginary is positive 20i. So remember the complex conjugate, I'll do the last one, it should be 21 minus 20i. You only change the sign of the imaginary part. Okay, next question. So we're going to solve the quadratic equations. So the first one that we have here, we will take the positive 50 across, that will turn it into a negative 50. Then you notice that 2 is multiplying to the x squared, so we're going to divide by 2. So negative 50 divided by 2, and that will give me x squared is equal to negative 25. Now, we know there's no real solution, right? Because we will have to take the square root, and we cannot take the square root of a negative number unless we use imaginary numbers. So we will use the square root of negative 1 times 25. The square root of 25 is 5, and the square root of negative 1 is I. However, here we're dealing with an unknown quantity, which is x, so we will consider both positive and negative 5i. So what this means is that we have x is equal to 5i, and x is equal to negative 5i. So, and another thing we could say about those two numbers is that they are complex conjugates.
Wait, miss, could you explain when you put the plus and minus sign?
Anytime you're dealing with an unknown quantity, such as x, we use both, plus and minus. If we're just dealing with numbers like we did here, we only use the positive square root. Okay, now next problem here, we have a negative 8, move it across, so that will be negative 3x squared is equal to 100 plus 8. 100 plus 8 is 108. Here, the negative 3 is multiplying the x squared, so we're going to divide. So that will give me negative 36. Here, we all know we need to take the square root to cancel the square. Here we factor negative 36 with negative 1 times 36. So we will get x is equal to the plus minus square root of 36, which is 6, square root of negative 1, which is I. So in reality, we have two solutions, positive 6i and negative 6i. Remember, imaginary solutions will always come in complex conjugates and pairs. Next problem here, we have what is the quadratic equation with the solutions positive 7i and negative 7i, which is no surprise because we've been saying they will always come in pairs, conjugate pairs. So if those are the solutions, the factors will be, remember, to get the factors, you take your solution and you move it across the equal sign so that it is with the x. So my first factor will be x minus 7i. And my second factor, if I take this negative 7i across the equal sign, it will turn it into positive 7i. So x plus 7i. So what I'm going to do now to find the function, or the equation, I'm going to multiply the factors. So this will be x squared plus 7xi minus 7xi minus 49i squared. Why is it minus? Because I'm multiplying negative 7 and positive 7. So negative 49i squared. Here I combine like terms, so the two in the middle, they cancel out because they're opposites. And here I have negative 49, and what did I tell you to substitute I squared with? Negative 1. So the final solution will be x squared plus 49. And I'm just going to draw a quick picture of how that will look. The positive 49 is a vertical shift, is shifting the equation up by 49 units. So the vertex will be somewhere here. And if you notice, that one has no x-intercepts, right? And we discussed last class that if you have no x-intercepts, that means that you have no real solutions. You still have to have solutions, so those solutions happen to be imaginary. Okay, I will do one more problem, and then I will let you be free. This paper here is very important for you to look at and go over. And so here is the quadratic formula. We already know where the a, b, and c come from. A is the coefficient of the x squared. Don't start packing your things, please. B is the coefficient of x, and c is the constant term. So by looking at the inside of the square root, which is called a radicand, or in this case, we call it the discriminant. Right here, highlight that part. If the discriminant is equal to 0, that means that you have one rational double root. If your discriminant is greater than 0, that means positive. That means that you're going to have two rational roots. If your discriminant is greater than 0, you will also have two roots, but they will be irrational. One thing I forgot to mention with the previous one is if you have a perfect square. That's why you get rational roots. If you don't have a perfect square, you get irrational roots. And the last one is if your discriminant is less than 0, then you will get two complex roots, but they will be imaginary. Okay, so this is the last problem I'm going to do. I promise. Okay, so we have the equation, and we're going to use the quadratic formula. You see, before that, we have converted to general form by equaling one side to 0. So we have 3x squared plus 7x. This negative 2, I take it across, so that will be plus 2, that is equal to 0. From here, we need to determine what is A, what is B, and what is C. A is equal to 3. B is equal to positive 7. And C is equal to positive 2. Now we use the quadratic formula, which is negative b plus minus the square root of b squared minus 4ac, everything divided by 2a. So after substituting, we will get this. Negative 7 for b plus minus the square root b squared. B is 7, so that will be 7 squared minus 4 times a times c. A is equal to 3. And C is equal to 2. Everything divided by 2 times A, and A is equal to 3. From here, I'm going to simplify a little bit, so it will be negative 7 plus minus, inside the square root, 7 squared is 49. And here, negative 4 times 3 is negative 12, times 2, negative 24. Everything divided by 6. So we have so far negative 7 plus minus. We take care of what's inside the radical. What is 49 minus 24? 25. So in this case, the discriminant is positive, and it happens to be a perfect square. What does that tell me according to the table? 2 rationals. So let's see. The square root of 25 is 5. Everything divided by 6. Remember, from here, you actually have 2 equations to deal with. One will be negative 7 plus 5 divided by 6, the one with a plus, and the other one will be the one with a minus, negative 7 minus 5, everything divided by 6. So the first one will be negative 7 plus 5, that is negative 2 over 6, so that is equal to negative 1/3. The next one will be negative 7 minus 5, that is equal to negative 12 over 6, and so that will be equal to negative 2. Those 2 are the solutions. For the next 3 problems, you're going to have to write them down on notebook paper, so take the time to write them down, pause the video if you have to. So I'm going to solve the quadratic equation again by using the formula. So before I can do that, I have to make sure one side is equal to 0. So I will take this positive 2x across. That will be negative 2x. Negative 2 across, that will turn into positive 2, and that way the side is equal to 0. From here, we need to, well, before we do that, let's go ahead and combine like terms. So negative 4x plus 2, that is equal to 0. Now, before applying the formula, we have to identify what a is equal to, which is the coefficient of the x squared. A is equal to 1. B is the coefficient of the x, so that will be a negative 4. And C is the constant term, which is 2. Now, with the quadratic formula, which is negative b plus minus the square root of b squared minus 4ac, everything divided by 2a. So we need to make sure to substitute the values for b, for a, and c. So that will be negative from the formula, the quadratic, and then negative 4. So negative times negative 4 plus minus the square root of negative 4 squared minus 4 times a, which is 1, times c, which is 2. From here, everything is divided by 2a. So I'm going to reduce this expression by multiplying negative times negative, that's positive, so positive 4 plus minus. Inside the radical, we have negative 4 squared, that's positive 16, minus 4 times 1 times 2, so that is equal to 8. Everything divided by 2. Then I'm going to subtract the two numbers inside the radical. So 16 minus 8 is equal to 8. Everything still remain divided by 2. What I'm going to do next is I'm going to rewrite 8. I'm going to take two factors so that one of them is a perfect square so that I can take the square root from one of the numbers. And we do this to simplify the expression. So 4 plus minus, now the square root of 4 is 2. And this other 2 is going to remain inside the radical. And in this case, you could see the discriminant is a positive number, so that tells me I get two real solutions. But since 8 is not a perfect square, my solutions will be irrational. Here I'm going to split the fraction, so it will be 4 divided by 2 plus minus 2 divided by 2 times the square root of 2. In this case, the only number that gets divided is the 2. So from here, 4 divided by 2 is 2 plus minus 2 divided by 2 is 1, so 1 times the square root of 2. From here, we could say that we have two zeros. One of them will be x is equal to 2 plus the square root of 2, and the other will be x is equal to 2 minus the square root of 2. And another interesting fact about irrational zeros is that they always come in pairs, just like imaginary numbers do. So irrational, they also come in conjugate pairs. Now for the next problem, I'm going to start the same way, so I have to make sure one side is equal to 0 before I can substitute anything into the quadratic. So a is equal to 1, the coefficient of the x squared, b is equal to negative 14, and c is equal to 58. So substitute in the quadratic, negative b plus minus the square root of b squared minus 4ac, everything divided by 2a. So this will be negative times negative 14 plus minus the square root of negative 14 squared minus 4 times 1 times 58. And everything will be divided by 2 times 1. So positive 14 and the square root. So negative 14 squared, that is 196. I calculated that in my head. And then, no, I'm just kidding. So negative 4 times 1 times 58, that will be negative 200 and 232. Thank you. Everything divided by 2. Now, could someone please do this operation, 196 minus 232?
Negative 36.
Negative 36, thank you. Remember, everything is still divided by 2. So here, 14, I'm going to simplify the square root of negative 36. So as we've seen before, that is going to turn into 6i. Everything divided by 2. So here we will have 14 divided by 2 plus minus 6 over 2 times I. And that will give us that x is equal to 7 plus minus 3i. Don't forget, from here we get two solutions. One of them is 7 plus 3i, and the other one is 7 minus 3i. Remember, they are imaginary solutions, so they do come in complex conjugates. Just the last question that we have here. Given a quadratic equation with rational coefficients and a root of 3 plus 5i, the way we solve this, well, to answer the first question with another root, remember the common conjugate pair, so the other root will be 3 minus 5i. What are the factors of the equation? So the factors of the equation will be x. I take this positive 3 across, it will be negative 3. I take this negative 5i across, so it will be plus 5i. And the other factor is the one that comes from the 0 here, so that will be x minus 3 minus 5i. Those are the two factors. What is the quadratic equation with a given root? And what we need to do here is actually multiply the factors, one times the other. So it will be something like x times everything here. Then minus 3, I'm taking this minus 3 times everything here. And then we take plus 5i times everything here again. So x minus 3 minus 5i. That will give us x squared minus 3x minus 5xi minus 3x plus 9 plus 15i plus 5xi minus 15i minus 25i squared. We could go ahead and combine like terms, so we can see that some things have opposite signs, so therefore they equal 0, or you may say they cancel. I believe here, no, that's correct. Is there anything else I can cancel out? I don't think so. No? Okay, so then the solution for this product is going to be x squared. I could combine the negative 3x, so that would be minus 6x. And then right here, remember I told you that will be substituted to negative 25 times negative 1. So that is in fact positive 25. So 25 plus 9, and that will equal to 34. So this will be the quadratic equation that comes from it. And so this is the end of the video.